Okay, this is the review video for how to do absolute value inequalities. So to be able to do absolute value inequalities, you need to understand what an absolute value is. And remember that the absolute value means the distance from zero. So if we're looking at a number line, and here is 0, if I want a distance of 2, I can go in the positive direction to 2, or I can go in the negative direction to -2. Both of these values have a distance of 2. So we're going to be having 2 points on our graph this time. So let's start with -8 plus x is less than 11. Okay? So to solve this, we're going to solve it exactly like we did inequalities. But because of the fact that we have 2 directions that our number line can go, we're going to need 2 different equations. So my first equation is 8 plus x is less than 11. So it's exactly the same as what we have here. That gives me my positive direction. Now I have a second one of -8 plus x, but this time I'm going to go in the negative direction, so that 11 changes to a -11. And if you remember back with inequalities, whenever something gets changed to a negative or gets multiplied by a negative, that inequality has to flip. So now it goes that way. And now we solve each one. So I'm going to add 8 to both sides. And that gives me x is less than 19. I'm going to add 8 here. And x is greater than -3. So there's our 2 solutions. Now the rules for graphing them on a number line are exactly the same as any inequalities. If it's less than or greater than, they're open. If it's less than or equal to or greater than or equal to, they're closed. Okay, so I'm going to make my number line. All right, and let's say that this is -3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do this let's count by 2s. So this would be -2, -4, -6, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. All right, so these are going to be open at 19, so 19 is right about there. And at -3, which is between -2 and -4, so right there. And just like with our inequalities, we have to test a point. So I'm going to put a point in the middle. And the reason we're going to do the point in the middle is that with our graph, what happens is all of our, I'm going to zoom out here so you can see what I'm going to do. If my hands are my points and my thumbs are my arrows are either going to look like this, where there's 2 points with a line in the middle, or they're going to look like this, 2 points with the line with the arrows going opposite directions. So either your graph is going to look like this or look like this. It will never be like this where the arrows are going the same direction. They're either like this or like this. All right. So again, our graph is going to be either like close point with arrows going opposite, open point, closed and closed. All of your graphs are going to look like this. They will never look any different than these four. Everything looks like this. And so to determine which one we have, we just pick a number between our 2 points. And an easy one to work with that's in the middle here, that's inside here, is 0. So I'm going to put 0 back in. And we're going to test it. And if it works, then that means that's where I need to shade. So absolute value of -8 is less than 11. Absolute value of -8 is 8, because it has a distance of 8 from 0. And 8 is less than 11, and that is yes. So that means I'm going to shade in the middle. Now the last thing I need to do is I have to write my solutions. And here's how your solutions are going to be. If you have a picture like this, then it is x is less than or equal to whatever that number is, or x is greater than or equal to the number. So this is the number on the left, this is the number on the right. If it's like this, it's just the other symbol. Okay, so these look the same. There's 2 arrows, so you're going to have 2 x's. Here, what happens is this is the left point. We're going to have number less than or equal to x less than or equal to x number. So there's one line, 1x. This one, okay, will look like that. So because our picture looks like this is my left number, so that's -3 is less than x is less than, this is my right number, and that is 19. And that is our solution. This and this is what I need to see. Okay, let's do the next one. We have here -6p minus 9 is greater or equal to 9. Okay, so now let's solve this. I'm going to zoom back in a little bit so you guys can see what's going on. I'm going to separate my absolute values. So I'm going to get -6p minus 9 is less than or equal to 9. And then I'm going to write my second one, -6p minus 9. Remember, this flips around to be less than or equal to -9. Solving each one, I'm going to add 9, -6p has to be greater or equal to 18. Divide by -6. And p is, now I divided by a negative, so because I divided by a negative, this has to flip around. -3. Okay, now let's do this one. Same thing, I'm going to add 9. -6p is less than or equal to 0. Divide by -6. And p is going to be, now again, we have to flip this around because we're divided by a negative. 0 divided by -6 is 0. Make our number line. So -3, -2, -1, and 0. My points this time are going to be closed. Now we want to test a point that's in between this, and that's either -1 or -2. And I'm going to try -1. So I'm going to put -1 back in here and see what happens. So -6 times -1 absolute value of that, oh, sorry, I forgot the minus 9, should be greater than or equal to 9. Negative times a negative makes it a positive, so that's 6 minus 9 has to be greater than or equal to 9. 6 minus 9, absolute value is negative 3, greater than or equal to 9. Absolute value of negative 3 is 3. So this answer is no. So it means my solutions are not inside here. They're going to be going the other way. So to write my solutions, I'm going to write x is less than or equal to my left number, or x is greater than or equal to my right number.